Okay, this video is two more examples of the same thing. So this one says to find all of the zeros of this polynomial using the rational zero theorem. So the rational zero theorem, again, is giving us a place to start. Okay, so plus or minus the factors of the constant, so P over Q, the leading coefficient. So factors of the constant are 1 and 3. And the factors of the leading coefficient is 1. So then our list to try are plus or minus 1 and plus or minus 3. Okay, so I'm going to let you pause the video here and try, do some guess and check to figure out which one is going to work. Okay, so now I'm going to go ahead and continue. What happens to work here is going to be -3. So I'm going to put my coefficients across the top and do synthetic division. So bring down the 1, multiply by the -3, add, we get 4, multiply by -3, we get -12, add, we get -1, multiply by -3, we get 3, and add, we get 0. So that means that -3 is a 0. That one works. So now we want to find the other zeros. So we're going to use this. This is our constant, our x, and our x squared. So we get x squared plus 4x minus 1. Okay, so remember we're solving to find the zeros. So we're going to try to factor it. If you look for factors of 1, it's 1 and 1. There's no way to add to 4. So it's not going to be possible for you to factor that. So then your other two options are your quadratic formula or completing the square. Okay, so this completing the square would not be bad at all for this one because our a value is 1 and our middle term is even. So that one is not bad at all. I'll go ahead and just do the quadratic formula so you can see that one again. Okay, so quadratic formula to solve for our other zeros. So x equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. So x is equal to -b, so our b is 4, so -4 plus or minus the square root of 4 squared minus 4 times a, which is 1, times c, which is -1, all over 2 times a, which is 1. So we'll simplify. We get -4 plus or minus, this is 16. -4 times 1 is -4, times -1 is +4. So this becomes +4. Okay, so we've got two negatives there. That becomes the plus. So if that is something that you tend to make a mistake on, type that into your calculator. Just remember, if you see two negatives, it's going to be a positive. Okay, so we end up with -4 plus or minus the square root of 20 all over 2. So now we got to simplify. So the square root of 20 simplifies to be 2 square root 5. And then all over 2. So now what we want to do is try to simplify this. So the -4 over 2, and then anything that's outside of the radical can be divided. So this one over 2. So you can also think of it as like -4 over 2 plus or minus 2 square root 5 over 2. And then you're simplifying that. So this gives me -2 plus or minus square root 5. So completing the square would have been much quicker, but I wanted to show you that quadratic formula again too. So either way is fine. Okay, so these are two different zeros. You have -2 plus square root of 5 and -2 minus square root of 5. And so you can write them as separate or together. And then the other zero that we have was -3. Okay, so this kind of shows our rational zero theorem. The possible rational zeros were plus or minus 1, plus or minus 3. If you tried them all, the only one that works is -3. But there are two other zeros because our degree is 3. So since our degree is 3, we had to use the quadratic formula to find those other zeros. So they happen to be irrational zeros. They could also have been imaginary, but the only rational zero came from that list. Okay, so let's do the last one. So this one in your notes packet is a different problem. So if you want to pause the video here and cross that one out and rewrite this one, we're going to find all of the real zeros using the rational zero theorem again. So now this one is just slightly different because it says find all of the real zeros. So if I find zeros that are not real, I don't want to list them like if in Pearson, if they're asking for real zeros and you put in the imaginary ones, it'll count it wrong. Okay. So there's kind of a hint there. So rational zero theorem. Again, we're going to do P over Q. Our Q is again 1. So I just need factors of 12. So factors of 12 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So this list is much longer than some of the other ones. So one of the things that you can do is just start trying at the beginning. That's usually where I'm going to find more. Another thing that you can do if the list is really long, especially in Pearson, I don't have control over how long the list is going to be, is you can type in your function into Desmos and see if you can figure out which one of those is a good place to start. So if you go to Desmos, and I'm going to show you that here, I typed that in, and you'll see where it crosses the x-axis. That's what we're looking for. We're looking for zeros. So it crosses at 3. So that is going to be one that should give me a remainder of 0. So this is a way to help you narrow down your list. While you're doing your homework, I would suggest that you try to do guess and check first, because that's what you'll have to do on your test. But since the list could be a much longer in Pearson, this is a way to check yourself. So now we're going to go back here, and we know that 3 is going to work. So I'm going to do my synthetic division, 1, -3, 4, and -12. And I'm going to bring down the 1 and then multiply by 3, which gives me 0 here when I add. 0, add, we get 4, multiply by 3, we get 12. So that gives me a remainder of 0. So I know that 3 is one of my zeros. So this is my constant, my x, and my x squared. So now what I have left is x squared plus 4, and I'm solving that equation. So there's no middle term here. So you could factor, it's not factorable. You could try to do the quadratic formula, but the easiest way here is using the square root method, just getting the x squared by itself. So I'm going to subtract the 4 to the other side. So I get x squared equals -4. And then I'm going to square root both sides. So when I square root the negative, that's going to take out the I. So square root of 4 is 2. The square root of -1 is I. And then remember that we always add a plus or minus when we take the square root of both sides of the equation. So these are 2 of my zeros. They are imaginary. And then my other 0 is 3. Since my degree is 3, I should only have 3 zeros. So those are my 3 zeros. So when you're giving your answer, it said just the real zeros. So my real 0 is x equals 3. That's the only real 0. If you look at the graph, you'll notice that that's the only time that it crosses the x-axis. So the other 2 zeros are imaginary. So you can tell that from the graph as well. Okay, so the whole idea here is that we're using the rational zero theorem to find one of the zeros, and then find the other ones once it's a quadratic, using any of your methods, square root method, quadratic formula, completing the square. Once you find the other 2, just make sure you look and see what it's asking for. So if it's asking for just all of the zeros or all of the real zeros. And you should be good to go. Please let me know if you have any questions.